Welcome. The next topic is common emitter configuration. Same like common base, we need to plot the input and output characteristics and the H parameters. For input characteristics, it's plotted between input voltage and input common emitter. So emitter is grounded, input in base, output in collector. Input characteristics is plotted between VBE and IB, keeping VCE constant. So it is like emitter based junction is forward biased and collector based junction reverse biased. So initially it is like a PN diode in forward bias only when VC equal to 0. So we get the same PN diode forward bias characteristic curve. As VCE increases, we give some voltage in the VCE and then note down the VBE and IB by changing VBB. Then the curve shifts towards the right side. For common base, it shifts towards the left side and here towards the right side, since this is drawn for VBE and IB now. And because of the early effect, base width reduces. So for the same value of VBE, we get IB little later for higher VCE value. And then output characteristics is plotted for the output voltage and output current VCE and IC, keeping the input current IB constant. So here we get a curve like this. There is some slope in the output characteristic curve, unlike the common emitter one, common base one, because alpha equal to beta by 1 plus beta and beta is alpha by 1 minus alpha. In common base, alpha value changes from 0.98 to 0.985. Here beta, the current gain of common emitter, changes from 49 to 66 for the same alpha values. So because of this large change, there is a slope in the output characteristic curve. And then this region is called the active region, where the transistor works as amplifier. This region is called cutoff region. Here emitter based junction is forward bias, collector based junction is reverse bias. Here emitter base, both the junctions are reverse biased, and here both the junctions are forward bias. So this is for the transistor to make us work as amplifier. Here in cutoff and saturation region, we switch it to make it work as a switch. And then beta is the current gain of common base configuration. So beta equal to IC by IE. The transistor parameters, HIE, the input impedances, del VBE by del IB, keeping VCE constant, unit ohm. Output admittance, so output current by output voltage, keeping IB constant, unit mho. Forward current gain, so output current by input current, keeping VCE constant and no unit. Reverse voltage gain, so this is del VBE, out reverse voltage gain, so input voltage divided by output voltage, keeping IB constant. So the next topic is common collector configuration. So here collector is common or grounded, input in base, output in emitter, and we measure the input and output characteristics. So input characteristics is drawn for VBE and VBC and IB, keeping VEC constant. Output characteristics is done for VCE and IE, keeping IB constant. And these are the comparison of common base, emitter and collector. Here the input resistance for common base is low, common emitter is moderate, for common collector it is high. Output characteristics for common base is high, moderate in CE and low in CC. Current gain is 1 in CB, high in CE and high in common collector. Voltage gain about nearly 150 for CB and CE and less than 1 for common collector. Phase shift is 180 between the input and output is 180 degree for common emitter. For common collector, in common collector base, there is no phase shift. Applications, it's used in base, it's used in high frequency circuit, CE for audio frequency circuits, and CC for impedance matching. So based on the requirement, we may choose the configuration which we require. Thank you.